Hello student, welcome to chemistry class. As you know that we are studying solution. In solution chapter we finished some starting topics. First definition of solution, type of solutions, and different type of solution on the basis of nature of solvent, and amount of solute and solvent, like the saturated, unsaturated solution, supersaturated solution, so many types. And then today we finish expression, methods of expression of concentrations, different methods, and in which we studied about the mass percentage, volume percentage, or you can say that mass by mass percentage, volume by volume percentage, mass by volume, and then mole fraction, molarity and molality. Now today we see the mole fraction, formula mole fraction, what is mole fraction. Then we see the numerical on these formulas. Okay. First is the mole fraction. Mole fraction. Mole fraction. What is mole fraction? It is a ratio of number of solute or solvent to the number of moles of solution, means sum of number of moles of solute and solvent. Okay, solute and solvent. In the form of formula, before writing this, it is denoted by X. By what? X. Suppose mole fraction of solute by X1, mole fraction of solvent X2, then mole fraction of solution, or you can say that total mole fraction is equal to X1 plus X2. Okay, one thing I will change here, X1 for the solvent and X2 for the solute. Now you can note that it is the ratio of solute, number of moles of solute or solvent to the number of moles of solution, means sum of the number of moles of solute and solvent, and it is denoted by X. Okay, mole fraction of solute is X2, mole fraction of solvent is X1. Total mole fraction is equal to X1 plus X2 is equal to 1, always 1. Okay, note down this. Have you noted? Now see the formula, some more formula in mole fraction. What is that? You can see here. First of all, we take the mole fraction X1, mole fraction of solvent, mole fraction of solvent. X1 is equal to number of moles of solvent upon number of moles of solvent plus number of moles of solute, where N1 is equal to number of moles of solute, number of moles of solute, N2 is equal to number of moles solvent. Here is solvent, 1 for solvent, always here remember this, for moles of solute. Okay, similarly moles, as you know that what is N is equal to given mass upon molar mass. Okay, as you know that. Now see here, you can write this formula W1 by M1 upon W2 W1 upon M1 plus W2 upon M2. Okay, this is the formula. Now X2, is it visible? Okay, X2 formula will be N2 upon N1 plus N2. In form of this formula will be W2 upon M2 upon W1 upon M1 plus W2 upon M2. This is the mole fraction of what? Mole fraction of solute. Okay, write down. This formula is good for dilute concentrated solution. This formula is only for the concentrated solution, not for dilute solution. For a dilute solution it is some different. What is that? You can write here for no. You can write here for no. These formulae are good for concentrated solution. Now see for the dilute solution. For the dilute solution, mole fraction for dilute solution. X2 is equal to N2 upon N1, where N2 is very less than N1, and you can write that W2 upon M2 upon W1 upon M1, or you can write W2 into M1 upon W1 into M2. This way you can write formula for the dilute solution. Okay, I will note down, then we will see some more. Okay, now some more formulas for the calculation of numericals. Now we'll see the relationship between molarity and mass percentage. Relationship between molarity and mass percentage. Okay, molarity and mass percentage. Then what will be the formula? Formula will be molarity, it is equal to percentage into density into 10 upon molar mass of solute, molar mass of solute. Okay, molar mass of solute. Where P is equal to percentage and D is equal to density. We will see questions. Okay, note down this. Now we will see here the relationship between molarity and molality. If you have write down, then I will erase this one. Okay, molarity and molality. Molarity and molarity. If you can use this formula, then you can solve any numerical very easily. Okay, what is the, as you know that molarity is denoted by capital M and molality is denoted by small m. Then molarity is equal to 1000 into molarity upon 1000 into density minus molarity into gram molecular mass. Gram molecular mass of solute. Okay, this is the relationship between molality. Here is molality, and this one is the molarity. Okay, this one is the molarity. Okay, molarity into gram molecular mass, or you can write molecular mass of solute. Okay, note down this. Now we will see the relationship between molarity and mass fraction. Relationship between molality, I think it is molality, small m, and mass fraction. And mass fraction. What is the formula? Formula is that mass fraction, here it is the here is the mole fraction, not mass fraction, mole fraction. Okay, X is going to here mole fraction of solute we will take here. Okay, then the formula is molality into gram molecular mass, GMM of, here is solvent, we will take solvent. Okay, and then here will be 1000 plus molality into gram molecular mass of solvent. This is the relation of the mole fraction and molarity. If you can use such type of formula, then you can solve any tough, difficult numerical on the molality. Okay, and you know that the normality is not in our course, so I left it. Then one more formula in the same reference, we are looking about the molecular mass, molality and mole fraction. Here you can write this formula in form of molality. This one is the molality. Okay, molality, and this is 1000 into mole fraction. B for, or you can write here solute in a bracket. Okay, now 1000 into mole solute, and then X of solvent, mole fraction of solvent, into gram molecular mass of solvent. Okay, one more relation between the mole fraction and mass fraction. For this you have to know, you should know the value of mole fraction of solute and solvent. Okay, then you can solve this. Now we will see here some more relationship. Dilution formula. Next is the dilution formula. Dilution, if you are diluting, or you can make a dilute solution. It means this formula is only for the dilute solution. Okay, only for the dilute solution. What is the formula? If the solution of some substance is diluted, of some substance is diluted by adding solvent. Okay, suppose you have to make a dilute solution of sugar. Then what you will do? Suppose you have some concentrated solution of the sugar, then you can add more and more water to make it dilute. Then how will we make? By adding. Then the solvent from volume V1 to V2. Then formula will be M1 M2 M1 V1 is equal to M2 V2. Because when we add more solvent, then the molarity of solution will be also changed. Suppose in first case there was molarity M1 when the volume was V1, then molarity will be V2 when the volume become, molarity will be M2 when volume become V2. This one is the very this volume is for the dilution. Okay, now suppose you have to write the formula of mixture. Okay, molarity of mixture. Molarity of mixture. Molarity of mixture. What will be the formula of molarity of mixture? What do you mean by mixture? It means some solution, or you can say there are two solutions. One solution whose molarity is M1, volume is V1. Another solution is M2, other solution whose molarity is M2 and volume is V2. Both are mixed to each other. Then after mixing, a solution is formed whose molarity will be different from the both solution which we added. Okay, once again, if you are mixing two solutions A and B, solution A have molarity M1, volume V1, and solution B have molarity M2 and V2, V is the volume. Okay, you can write in the different form. Suppose I am writing here, then you will be, if a solution if V1 ml of a solution of molarity M1, what V1 ml of a solution of molarity M1 is mixed with V2 ml of another solution of molarity V2 ml of another solution of molarity M2, then the molarity of mixture and you can write in bracket solution will be what? M. Then you can write M1 V1 plus M2 V2 equal to MV, where V is equal to V1 plus V2. You can write this formula M is equal to M1 V1 plus M2 V2 upon V, or you can write this like M1 V1 plus M2 V2 upon V1 plus V2. This way you can calculate the molarity of the mixture. It is different from the dilution formula. What were happening in the dilution formula? We are diluting the same solution, okay, whose molarity in the beginning was M1 and volume was V1. After adding some more solvent, its volume become V2 and molarity will be M2. Then that case you have to write M1 V1 is equal to M2 V2. But in case of mixture, where one solution has volume V1 and molarity M1, another solution has molarity M2 and volume V2, then after mixing a new solution is formed whose molarity will be M and volume will be V, where V is the sum of the volumes of the both solution what we mixed. Okay, so this is the formula of mixture. Okay, now we will see some more formulas, or first of all we see a numerical, otherwise there will be no use of such type of formula. Okay, here is a very small numerical. Calculate the mass percentage. Calculate the mass percentage of benzene. You know the formula of benzene C6H6. Okay, and carbon tetrafluoride H chloride. Okay. CCl4. If 22 gram of benzene is dissolved in 122 gram of CCl4 carbon tetrachloride, then the mass percentage of benzene is asked. Calculate the mass percentage of benzene, and formula will be mass percentage of benzene will be the mass of benzene. Here will be mass of benzene, then mass of benzene, and you can write C6H6 in form of formula, and mass of CCl4 4 into 100. Then the mass of benzene will be what? It will be 78. Oh, it is given. What is the mass? 22 plus, here will be 22 plus what? 122 equal to what? Into 100 equal to 22 upon 144 into 100. Now you can calculate this. It will be 15.28%. Okay, what you have to do, very easy question. Mass percentage of benzene is equal to mass of benzene plus mass of benzene and mass of CCl4. Here is the mass of benzene, here is the mass of CCl4 into 100. Then you have to put the volume value in the formula, then you will get the mass percentage. Suppose you have to calculate the mass percentage of CCl4 also, then the mass percentage of CCl4 also will be mass percentage of CCl4 will be 100 minus mass percent of benzene. Okay, here will be 100 minus what? 15.28. Okay, then you can calculate the value of this. It will be 84.72%. So student, we will see some more numericals in this chapter on a given formula. So it is enough for today. Next day we will present with new numericals. Thank you. Have a nice day.